Welcome to our trig review. We're going to go ahead and get started and talk about all the important things you should remember from trig, but you might not. Alright, for those of you who are unaware, SOHCAHTOA, it's only useful if you spell it correctly. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Here we have our three basic trig functions. Then we also have our reciprocal functions. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Keep in mind that secant goes with cosine and cosecant goes with sine. The cos don't go together. The c's don't go together there, so look out. And remember, when you divide by a fraction, because sine really means opposite over hypotenuse, you flip and multiply, which means that cosecant equals hypotenuse over opposite, secant equals hypotenuse over adjacent, and cotangent equals adjacent over hypotenuse. Those are our 6 trig functions we're going to be talking about here. Your 2 special right triangles are very, very important. We have the 45, 45, 90 right triangle. Remember, the 90 is the little square here, and our sides are 1, 1, square root of 2. The 30, 60, 90 is a little harder because most people forget about your sides. But remember, there's a relationship between the sides and the angles across from them. The 30 is the smallest angle, and 1 is the smallest side. 60 is the next largest angle, and square root of 3 is the next largest side. And then, of course, our 90-degree angle is the biggest angle, and 2 is the biggest side. Keeping in mind that square root of 3 is really about like 1.7-ish. All right, so using our special right triangles here, we have sine of 45 degrees. We go to our 45, 45, 90 right triangle. It doesn't matter which 45 we mark. You can use whichever one you like. The opposite side is the one directly across from the 45. The hypotenuse is the one directly across from the 90 degrees. And the adjacent side is the one left over, the one touching the 45. And since we want sine, we want opposite over hypotenuse. So we have 1 over the square root of 2. However, it needs to be rationalized. You can't have a radical in the denominator. So we're going to multiply by square root of 2 on top and square root of 2 on the bottom, which means we wind up with the square root of 2 divided by 2 for sine of 45. For cosine of 30 degrees, we're going to use our 30, 60, 90 right triangle. So we go over here and we mark our 30. Keeping in mind, again, we have the opposite side directly across from the 30. Our adjacent side right here with the square root of 3. And then our hypotenuse is the one across from the 90 degrees. For cosine, we want adjacent over hypotenuse. So we're going to get square root of 3 divided by 2 is my answer. It doesn't need to be rationalized because there's no square root on the bottom. Tangent of 60, we're going to use that same triangle, except for this time, I'm going to use the 60 degree. Now the hypotenuse stays the same. The hypotenuse is always across from the 90 degrees. However, now the side opposite of the 60 degrees is the square root of 3. This is now the opposite. Now the one left over, the one touching it, the 1 is the adjacent side. So the hypotenuse stayed the same, and the sides switch there in terms of your reference angle. So we have tangent of 60 degrees. Tangent is opposite over adjacent, so I'm going to have square root of 3 divided by 1, but square root of 3 divided by 1 is just square root of 3. If theta is positive, and we're talking about being in standard form, then the initial side is the positive x-axis, and we rotate counterclockwise. Again, that is if theta is positive. If theta is negative, the initial side is still on the positive x-axis, and we rotate clockwise. Quadrantals. Remember, you've got your unit circle. Your unit circle is a circle centered at the origin with a radius of 1, which means we go out to 1, 0, then we go up to 0, 1, to the left, negative 1, 0, and to the right, 0, negative 1. There are 360 degrees in a circle and 4 quadrants. So when we divide 360 by 4, there are 90 degrees in each quadrant. So we start at 0 degrees, go up to 90 degrees, another 90 degrees gets us to 180, another 90 degrees gets us to 270, and then another 90 degrees gets us back to our 360. Important things to know. Cosine are my x values. Sine are my y values. And I would star, underline, highlight this. Tangent is always y over x, or sine over cosine. A lot of people get this confused, so look at it. It's always sine divided by cosine. So, for example number 4, notice we've got our quadrantals over there for us, and it says sine of negative 90 degrees. Since our theta is negative, we are not going to go counterclockwise. Instead, we are going to go clockwise. And negative 90 degrees is actually the same thing as 270. Sine is our y value, and at 270, our y value here we can see is negative 1. So sine of negative 90 is negative 1. Then we have cosine of 180 degrees. We start at 0 and we rotate counterclockwise because it's positive, 180 degrees. Cosine is my x value there. So cosine of 180 degrees is negative 1. For tangent of 270, again, we start at the positive x-axis and we're going to rotate counterclockwise because it's positive till we get to 270. Now, tangent's a little harder. You don't just look at the point and know it. Instead, we have to do y divided by x. And here y is negative 1 and x is 0. Never, 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 never leave negative 1 divided by 0, because when 0 is under the line, that means it's undefined, which means we don't write negative 1, 0. Instead, we write undefined. And you are welcome to abbreviate it. I usually do UND, but the correct answer there for tangent is undefined. Do not leave negative 1 divided by 0 on your paper. You must always simplify. All right, so to help you out with some signs here, A smart trig class. A smart trig class. All right, so in the first quadrant, all 6 of my trig functions are positive. In the second quadrant, only sine and its reciprocal cosecant are positive. In the third quadrant, tangent and its reciprocal cotangent are positive. And in the fourth quadrant, only cosine and secant are positive. Always look out for your signs. This is the #1 place where students make a lot of careless mistakes. Either they've messed up their triangle or they don't know about their signs. So look out for your signs here. All right. Give the values of the 6 trig functions of an angle in standard position with a given point on the terminal side. That's a lot of directions. All right. Well, we've got an ordered pair. And we've got an ordered pair. Maybe I should plot it. So I'm going to draw the coordinate plane. And I'm not going to make 8 little dashes or 15 little dashes. That just seems like too much. Instead, I know they're both positive. So I'm going to the right 8 units. Then I'm going up 15 units. And there's my point. And hopefully you can start to see that I have a triangle here. Hopefully you can see that I have my triangle here. All right, I've got 2 sides of a right triangle. And if I want to find the third side, because maybe that might be useful, because I'm going to be finding my trig function, so I'm going to need my hypotenuse. How might I go about finding that third side? Yeah, exactly. I might use the Pythagorean theorem. So here I have both legs. Doesn't matter which one you call which. So I have 8 squared plus 15 squared equals x squared, and you can call it c squared if you like. Totally up to you there. 8 squared is 64. 15 squared is 225 equals x squared. All right, scroll up here. Add them up, that gives me 289 equals x squared. Take a square root. Now, typically when you take a square root, you put a plus or minus up front. However, we're talking about the hypotenuse. We're talking about a length here, so it is not going to be negative. The hypotenuse is never negative there. So the square root of 289, anybody know the square root of 289? 17, very good. So I'm going to put a 17 up there for my hypotenuse. So now it wants the 6 trig functions. So I'm going to go ahead and write them out. So I have sine of theta. Notice you never leave it empty. Always give it an angle in there. Then we have cosine of theta, tangent of theta. In the same way we can do our reciprocal. So I'm going to do cosecant theta, secant of theta, and cotangent of theta. All right, remember here we have our angle, our opposite, our adjacent, and our hypotenuse. So for sine, we have opposite over hypotenuse, so that gives me 15 over 17. And while I'm here, I know that cosecant is its reciprocal, so I can just flip it over to get cosecant. Cosecant is going to be 17 over 15. In the same way, we have cosine, adjacent over hypotenuse. That's going to give me 8 over 17. To find its reciprocal secant, I just flip it over, so that gives me 17 over 8. For tangent, I have opposite over adjacent, so that gives me 15 over 8. And for cotangent, to get its reciprocal, I just flip it on over, and I get 8 over 15. I have now found the values of all 6 of my trigonometric functions, so I'm good to go. For number 8 here, give the values, okay, same direction, same nonsense they're asking you for, but this time is my point in the first quadrant. No, very good. The x value is negative, and when the x is negative, that means I go to the left. Y value is positive, so now I'm in the second quadrant, so that's something to look out for there. So this time, I'm not in the first quadrant, I'm in the second quadrant. I went to the left 4, and I'm going to go ahead and write my -4 there, and then I went up 5, so there's my point, and there's my triangle. Sorry, my triangle's not super cute. We're going to try our best and see what we can do there. Just like on the last one, it's a good idea to start by finding the missing side of your triangle. Again, we've got the 2 legs, so I'm going to go for the Pythagorean theorem. So I have -4 squared plus 5 squared equals x squared or c squared or whatever. Some people like to call it r. It's up to you there. -4 squared. Be very careful about that. Whenever you square a negative, it always becomes positive, so look out. So you have 16 plus 25 equals x squared. All right, 16 plus 25, well, that gives me 35. That gives me 41, I do believe. Yes, that gives me 41 equals x squared. Take a square root. Again, we don't need the plus or minus because we're talking about the hypotenuse. So this means that my hypotenuse is the square root of 41. Look out for your negative. Look out for your negative. Look out, look out, look out for your negative. Again, here we're going to have sine of theta, cosine of theta, tangent of theta. Don't forget your theta. Every time, always put that theta. Then we have cosecant of theta, secant of theta, and cotangent of theta. All right, so sine, remember here's our angle, here's the opposite, here's the adjacent, and here's my hypotenuse. Now in the second quadrant, I know that sine and its reciprocal are the only ones that are positive. That means every other one is going to be negative. So a lot of times I'll go ahead and just put a minus sign up there for the ones I know that are going to be negative, so I don't make a careless mistake with my negative. So look out with that. All right, so for sine, opposite over hypotenuse. So I get 5 over the square root of 41. I can't leave my answer like that. I have a radical on the bottom. So I'm going to multiply by the square root of 41 on the top and the bottom. So I get 5 square roots of 41 divided by 41. So there is sine of theta. To get to my reciprocal, I'm going to take my non-rationalized form and just flip it over. So it becomes square root of 41 divided by 5. For cosine, I have adjacent over hypotenuse. Oh, look, there's that -4. I already knew it was going to be negative. Keeps me from making that mistake. Rationalize, and I get -4 square roots of 41 divided by 41. Take the unrationalized form and flip it over to get secant. It's reciprocal. So I get negative square root of 41 divided by 4. Notice I like to put the negative on top. You don't have to do that. You can put the negative on the bottom or just out front. So long as it's there somewhere, it doesn't really matter to me. Just make sure you have that negative. For tangent, we have opposite over adjacent, so that gives me 5 over -4. Again, I like to put the negative on top. You can put it wherever you want. We can go ahead and flip it over to get its reciprocal here. So we have 4 over 5. Again, I already knew it was going to be negative. That negative sign is already there. All right, number 9. Find the value of the remaining trig functions given the following information about theta. Tangent of theta equals -2/3, and theta is in the second quadrant. Well, that's nice. They told us where we're located. So I can go ahead, and I know I'm going to be in the second quadrant, and I'm going to have a triangle over here. So I'm going to go to the second quadrant, and I'm going to draw a triangle. Now what they've also told me is that tangent of theta is -2 over 3. Well, tangent is opposite divided by adjacent. So I know if this is my angle, my opposite side, well, it says it's going to be -2. But remember, we said just a minute ago that the negative could go on top or on the bottom. And I know that this 2 has to be positive. The reason I know that is because I went up. I went up. That means in the y direction, that is a positive number. And that negative actually has to go with my x, because if I go to the left on the x-axis, then it must be negative. Again, I have 2 sides of a right triangle. I can go ahead and use the Pythagorean theorem to find the third side. So, again, I've got 2 squared plus -3 squared equals x squared. That gives me 4 plus 9 equals x squared. So that gives me x squared equals 13. Take a square root. So x equals the square root of 13. Again, I can fill in my picture, keeping in mind the hypotenuse is always positive. Here's my opposite, here's my adjacent. Now we talked about this on the last example. We're in the second quadrant, so we know which trig functions are positive. And I'm writing down tangent, even though I already know tangent, that's okay. It's kind of just having to have it. Up to you how you want to do that there. So there's secant of theta, and there's cotangent of theta. I'm going to start with the easy one. I'm going to start with the given one. I know that tangent is negative 2/3. And if I know that tangent is negative 2/3, I can go ahead and flip it over, and I can get cotangent, which I'm going to write as negative 3/2. Again, up to you where you want to put the negative, so long as you have it. For sine, we're going to use opposite over hypotenuse. So I have 2 divided by the square root of 13. But of course, I got to rationalize, multiply by the square root of 13. So I have 2 square roots of 13 divided by 13. For cosecant, I flip over the unrationalized version, and I get square root of 13 divided by 2. Remember we said a smart trig class in the second quadrant, sine and its reciprocal are positive, which sure enough, they came out positive. That means cosine, secant, tangent, and cotangent are negative. Oh look, these are already negative. I already knew that. Let's see what happens with cosine. So cosine is adjacent over hypotenuse, so I get negative 3 over the square root of 13. Rationalized by multiplying by the square root of 13, so I get negative 3 square roots of 13 divided by 13. Oh yeah, it's negative. Flip over to get the reciprocal here, the unrationalized version, so I get negative square root of 13 divided by 3. Again, if you're watching your negatives, your signs come out easily. If not, always double check that you have the correct signs here. It's very easy to make a sign error, and that's what most people tend to do. All right, radians. The radian is a standard unit of angular measure. So if you're in degrees, then you need to have a degree mark. If you're in radians, you don't need a degree mark. And now we're going to talk about how to get from degrees to radians. So you take the degree measure and divide by 180. Then all you got to do is put a pi next to your answer. So we're going to divide by 180. All right, so number 10, convert the following angles from degrees to radians. I know that they're in degrees because they have the little degree sign. That's how I already know they're in degrees. So I'm going to change them into radians. And to do that, all we got to do is divide by 180. Well, 18 and 180 have 18 in common. So 18 divided by 18 is 1. 180 divided by 18 is 10. And then I just throw a pi out back. 1 over 10 pi is absolutely correct. However, math people don't tend to write it that way. This 1 is kind of a placeholder, and they're kind of lazy. So most math people are going to write it as pi over 10. That's how you're going to see it written, as pi over 10. For number 11, very similar. Again, we're just going to start by dividing by 180. I can see clearly that they have a 0 in common. So now I have 15 over 18. And now they have a 3 in common. And again, if you can do it all together, great. Just want a baby step for people who have trouble simplifying their fractions there. So 15 divided by 3 is 5. 18 divided by 3 is 6. And then I just throw a pi up there. So I have 5 pi divided by 6. 5 pi divided by 6. For number 12, we'll just scroll down for you. Again, divide by 180. I can see that they have a 0 at back. That means they're both divisible by 10. So I can go ahead and call this 33 over 18. And again, they both have a 3 in common. So I divide. 33 divided by 3 is 11. 18 divided by 3 is 6. And then throw a pi up top. 11 pi over 6. Now might be a good time for you to pause the video and try number 13 on your own. Okay, assuming you tried it, let's go through it here. So we divide by 180. They have a 0 in common, so that gives me negative 15 divided by 18. They don't have anything in common. I just throw a pi up top. Negative 5 pi over 18. All right, so now we're going to go the other way. And this one might be a little bit harder for you. It depends on how good you are with your fractions. We'll see. So to get from radians to degrees, take the number next to the pi and multiply by 180. So we're going to drop the pi and multiply by 180. That's all we got to do. So here, this means I have 1 over 9, because we're dropping the pi, and we're multiplying by 180. Well, this is really like 180 divided by 9, because the 9 is on the bottom. So 180 divided by 9. Well, I know that 9 goes into 18 twice, and then there's a 0 there. So that's going to give me 20 degrees. And because we're in degrees, make sure you use the degree sign. Make sure you use the degree sign. Make sure you use the degree sign. All right, for number 15, we're getting rid of the pi and we're multiplying by 180. All right, so for this one, again, I don't know what 11 times 180 is. That's too hard for me. I'm not going to try that. Instead, I'm going to say 180 divided by 6. So what's 180 divided by 6? Well, 6 goes to 18 three times. There's a 0, so that's 30. And now I have 11 times 30. Again, 11 times 30, I maybe don't know, and you're welcome to type in your calculator, your little blue 4 function if you want there. But I know that 10 times 30 is 300. Add another 30, so that gives me 330 degrees. Don't forget your degree sign. Don't forget your degree sign. Don't forget. Or if you just know about 11 times 3 and then add a 0, same deal. Doesn't matter how you do it. Number 16. All right, drop the pi, multiplying by 180. All right, 180 divided by 4. 180 divided by 4. Well, I know 180 divided by 2 is 90. 90 divided by 2 is 45. So 180 divided by 2, or by 4, excuse me, is 45. And now I have 3 times 45. If you need to type it into your calculator, please feel free. Just practicing our arithmetic. 3 times 45. Well, I know 45 times 2 is 90. If I add another one to that, I get 135 degrees. There it is. Again, now might be a great time for you to pause the video and try number 17 on your own. Assuming you've tried it out, we're going to drop that pi and multiply by 180. Now this time, there's nothing to cancel with. So we just have to multiply 180 times 4. Well, I know 180 times 2 is 360, and 360 plus 360 is 720. There's a negative out front, so negative 720 degrees. Again, feel free to use your little 4-function calculator. No big deal. Just practicing our arithmetic. All right, coterminal angles. These are very important. You want to listen up for these here. Two angles with the same initial and terminal sides, but different rotations. You find them by adding or subtracting until theta is between 0 and 360 degrees here. So 415, this is more than 360. So I'm going to subtract 360 from it. So I'm going to subtract 360 degrees. So 5 minus 0 is 5. I can't say 1 minus 6, so I'm going to borrow. And then 11 minus 6 gives me 5. So that means I have 55 degrees is my coterminal angle between 0 and 360. That means they end in the same spot. This one is just on my unit circle between 0 to 360. It's more helpful. Number 19 is a negative number. So subtracting 360 isn't going to help me. Instead, I need to add 360. But taking a negative number and adding a number to it is the same as subtraction there. So I'm just going to say 360 minus 160 here, which is going to give me 0, 0, 2. Oh, look, 200 degrees is my coterminal angle. 200 degrees is my coterminal angle. Now, number 20 and 21 might look a little funny because they're in radians. So adding and subtracting 360 degrees is not very useful because, well, I'm in degrees and these are clearly in radians. I have no degree mark. I've got my little pi. I'm in radians. So instead of adding and subtracting 360, I'm going to add and subtract 2 pi because 2 pi equals 360 in radians there. So I'm going to add, because it's negative here, I'm going to add 2 pi. But wait, there's a fraction. Remember, when you're going to add fractions, you need to have like denominators. So we're going to multiply our 2 pi by 6 over 6. So this is really negative 25 pi over 6 plus 2 pi times 6 is 12 pi over 6. And here I have negative 25 plus 12. That means I'm going to have a negative 13 pi over 6, which is still not in my unit circle. It's still not between 0 and 2 pi, which is the same as 0 and 360. So I'm going to add 12 pi over 6 again. And when I do that this time, scroll up for you a little bit there. All right, when I do that again this time, I still get negative pi over 6, which is not between 0 and 2 pi or 0 and 360. So again, I've got to add 12 pi over 6. And when I do that this time, I wind up with 11 pi over 6, which is between 0 and 2 pi or 0 and 360, so I'm good. Again, now might be a great time for you to pause the video and try number 21. All right, for those of you who tried it, number 21 here, we're going to be subtracting 2 pi. But remember, it's a fraction, so I've got to multiply by 5 over 5. And again, I know I've got to subtract because this number is too big, and I need to make it smaller by subtracting my 2 pi. So I have 17 pi over 5 minus 10 pi over 5. And 17 pi over 5 minus 10 pi over 5 gives me 7 pi over 5, which is between 0 and 2 pi. So I'm good to go. That's it. A reference angle is also very important. The reference angle, the most important thing about it, it is an acute positive angle formed by the terminal side and the x-axis, the x-axis, the x-axis, the x-axis. Make sure that you make yourself a little note there. So number 22, 23, and 24, they want us to find the reference angle. This is not a coterminal angle. We're not finding something that ends in the same spot. Instead, we're finding how far it is to the x-axis. So here we have 345 degrees. Well, 345 degrees is almost 360, so I am in the 4th quadrant. So I come over here to the 4th quadrant, and I draw my angle. And it's just an approximation. I know that this bit is 345 degrees. So if I want to find my reference angle, what that's asking me is for the distance from the terminal side to the x-axis. Well, how many degrees are in a circle altogether? That's right, 360. So what do you think we're going to do to get this angle here? Very good. We're going to say 360 degrees minus 345 degrees, and that gives me 15 degrees. That is my reference angle. That is my 15 degrees right there. And I'll scroll down a little bit so you can see better. Number 23 is a little harder because it's in radians, and a lot of people get confused about that, and that's okay. So radians here, if you notice, this is 5 over 6. Well, 6 over 6 would be 1. So I know that I'm less than 1, and 5 over 6 is real close to 1, so that puts me in the 2nd quadrant. So here I am in the 2nd quadrant. This is 5 pi over 6, which means if I want to find my reference angle, I want to find the distance to the x-axis. So in degrees, we have 0, 90, and 180 degrees, but in radians, I have 0, pi over 2, and pi. This is pi. So if I want to find my reference angle, all I have to do is say pi minus 5 pi over 6. Keeping in mind, I could rewrite my pi as 6 pi over 6, and 6 pi over 6 minus 5 pi over 6 is pi over 6. So my reference angle here is pi over 6. Number 24. Okay, number 24, if you can do it without making a coterminal angle, that's fine, but a lot of people get confused about what quadrant it's in because it's negative. So a good first step might be to find a coterminal angle by adding 360 degrees. And we said when you do that, it's really like the same thing as subtracting there, so we can write it the other way if you prefer, if that helps you feel better about it. So we have 360 minus 135, so I'm going to borrow here. 10 minus 5 is 5. 5 minus 3 is 2, and then 2. So we have 225 degrees. 225 degrees is in the 3rd quadrant because I have 0, 90, 180, 270, and 225 is between 180 and 270. So this time, if I want to find my reference angle, here it is. It's the distance between the terminal side and the x-axis. And if this whole thing is 225, and I know this line is 180, then all I have to do is subtract, and I can say 225 minus 180. So 225 minus 180 degrees. Well, 5 minus 0 is 5. I can't do the 2 there, so I borrow. 12 minus 8 is 4, so I wind up with 45 degrees. So my reference angle is 45 degrees. If you need to pause and go through any of the previous information, now would be a great time. Because on the next example, we're going to take all of this information and kind of squash it together in order to find exact values. And exact values are the pinnacle of trig. This is the most important thing that we are going to do here. So it says cosine of 2 pi over 3. First things first, I need to know what quadrant 2 pi over 3 is. Well, it's 2/3, so it's more than a half and less than a whole. So I'm over here in the 2nd quadrant. So here is 2 pi over 3. Now, I need to find a reference angle. And in order to do that, remember we talked about this is pi. So to find the reference angle, I'm going to say pi minus 2 pi over 3. That's really like 3 pi over 3 minus 2 pi over 3, which gives me pi over 3. But wait, that might ring a bell, because pi over 3. So as we were just saying, these are two special right triangles in degrees, but now that we know about how to go from degrees to radians, now we could write these same triangles in radians. So 45 is pi over 4. So this is our pi over 4, pi over 4, pi over 2 right triangle. Same information, except for I'm just writing the degrees in a different way. I'm writing the angles there. 30 degrees, all right, if I divide by 180, that is the same as pi over 6. And for 60 degrees, that is the same as pi over 3. A lot of people try to put the pi over 6 with the 60 and the pi over 3 with the 30, but that's not how it goes. So be careful that you have it right. So now going back to example number 25 here, the reference angle is pi over 3, which means now I have a special right triangle. And pi over 3 is like 60 degrees, so pi over 3 across from that is going to be my square root of 3. Across from my pi over 6 is going to be my 1. But wait, I went to the left, so it's actually a negative 1 here. And then my hypotenuse is a 2. And since it's asking me for cosine, I want the adjacent over the hypotenuse, which means my answer is a negative 1/2. Be sure to double check your signs with a smart trig class. In the second quadrant, we knew that cosine was going to be negative, so I know there's a negative there. Number 26 is also in the second quadrant. So here we are with 5 pi over 6, and that means this is 5 pi over 6. If I want my reference angle, I just subtract from pi, so I can say pi minus 5 pi over 6. Keeping in mind that pi is 6 pi over 6, that means my reference angle gives me pi over 6. So if this is pi over 6, that means I can make my right triangle here. Sorry, I drew it a little funny. Right across from the pi over 6 is my 1. Across from the pi over 3, the other angle is my square root of 3. But again, we're in the second quadrant, so this one is negative. I go to the left, it is negative there. And then my hypotenuse is, of course, a 2. I want sine. Sine is opposite over hypotenuse, so sine of 5 pi over 6 gives me a positive 1/2. I knew it was going to be positive because I'm in the second quadrant. And a smart, sine and its reciprocal are both positive in the third quadrant, or excuse me, in the second quadrant there. All right, for tangent here we have 5 pi over 4. 5 over 4 is just past 1, which means I'm going to be down here in the third quadrant. So this angle is 5 pi over 4. That means to find my reference angle, I'm going to say 5 pi over 4 minus pi, which I can write as 4 pi over 4, gives me pi over 4. So my reference angle is pi over 4. That means there's my special right triangle. My pi over 4, pi over 4, pi over 2. So that means I have 1, 1, square root of 2. However, I'm in the third quadrant, so I went to the left on the x-axis, so it gets a negative. I went down on the y-axis, so it gets a negative. I want tangent. Tangent is opposite over adjacent, so that gives me negative 1 divided by 1. Well, what's negative 1 divided by 1? Sure enough, it is just 1. Very good. Example number 27 is just 1. Oh, there are triangles again, just as a reminder. All right, number 28. We have secant of 11 pi over 6. All right, what quadrant is 11 pi over 6 in? Well, I know that 12 over 6 is 2, so it's really close to 2 pi there. So that means I'm over here in the fourth quadrant. Here's my 11 pi over 6, which means if I want to find the reference angle, how am I going to do that here? Good, very good. I'm going to take 2 pi, and I'm going to subtract 11 pi over 6. Sorry about that, I forgot to write my 11. All right, so 11 pi over 6. Keeping in mind, I can rewrite 2 pi as 12 pi over 6. So 12 pi over 6 minus 11 pi over 6 gives me pi over 6. That should ring a bell. That's one of the angles in my special right triangles. All right, across from the pi over 6. Okay, across from pi over 6 is going to be my 1. But because I went down, it's going to be a negative 1. All right, across my adjacent side here, across from the pi over 3 is going to be my square root of 3. It's positive because I went to the right on the x-axis. And my hypotenuse is a 2. Now, I don't love thinking about secant personally. It's really hard for me to think about the reciprocals looking at a triangle. Instead, I think about its reciprocal. And the reciprocal of secant is cosine. So I have cosine of theta equals, well, cosine is adjacent over hypotenuse, so that gives me square root of 3 over 2. Since it is secant, I'm going to flip it over, but when I flip it over, I get 2 over the square root of 3. So what do I have to do when I get 2 over the square root of 3? Well, of course, I have to rationalize it. So this becomes 2 square root of 3 divided by 3. Notice I resulted in a positive answer. A smart trig class. Well, cosine and its reciprocal are both positive in the fourth quadrant. That's why. If you can, go ahead and pause the video and see if you can try number 29. All right, hope you got it. Let's try. We have 9 pi over 4. 9 pi over 4, wait a sec. Is that between 0 and 2 pi? I don't think so, because 8 over 4 would be 2 pi. But we got 9 over 4. So first things first, might be a good idea to get a coterminal angle. So we have 9 pi over 4. And we're going to subtract 2 pi, but in this case that's 8 pi over 4. So now we're really looking for pi over 4. Oh, well that makes it way easy, because where's pi over 4? That's right. Pi over 4 is in the first quadrant. So here's pi over 4. And that means I've got my special right triangle, 1, 1, square root of 2, no negatives because we're in the first quadrant. And I want cosecant. Again, cosecant isn't my favorite to think about. It's difficult for me. So I'm going to use its reciprocal sine. So I know that sine of theta, in this case, sine is 1 over the square root of 2. I'm not going to worry about rationalizing because sine isn't my answer. Instead, I flip it over, which means that cosecant equals the square root of 2 over 1, or just the square root of 2. All right, 30 and 31 are a little bit different. You notice you don't have a lot of room for them. That's because these are known as quadrantals. They are just your points. So at 0 radians, here's my ordered pair. Remember, I was at 1, 0. And tangent is y divided by x. So here we have 0 divided by 1. Just like we didn't leave 1 divided by 0, we're not going to leave 0 divided by 1, because 0 divided by 1 is, I really hope you said 0. If not, check it out on your calculator. 0 divided by 1 is 0. And number 31, last one here. All right, cosine of 3 pi over 2. Well, 3 pi over 2 is on my unit circle, but you're not going to find it on a special right triangle. Again, it's one of our quadrantals. 3 pi over 2 is the same as 270. So 0, pi over 2, pi, 3 pi over 2, here we are. So my ordered pair is 0, negative 1. Cosine is the x value, so my answer is just 0. If you need extra help, please hit me up on Remind and or come on down to Study Hall and we can help you out. Thanks for listening. If you have any questions, please let me know.